All right. Feel like we good now. Um, how does that look to you guys? Should I turn off these lights? Why don't you move so backwards? People on this side of this side. There's something. What a day, what a day, what a day. All right, so even though I did speak about this real quick, I'm just gonna repeat myself for the recording. All right. So again, tutoring is now open, right? And the hours are gonna be Monday through Thursday, right? 11 a.m. to 8 p.m. And that's in CPH 303 if you want to go in person. Online is going to be via Zoom. To get the link for the online tutoring, you have to make an appointment. Friday through Saturday, right, is going to be 12 p.m. to 6 p.m. Same room, CPH 303. And again, if you want to do it online, make the appointment, you get the link online and that's it. The website to do the online is WC Online. So hold on, let me get that for you real quick. Well, just bear with me 1 second. I'm going to get that for you. I believe I showed it last time, but just in case you don't remember, I'm just going to show that again. Let me stop sharing. I'm going to share one more time. So just to recap real quick, right? This is WC Online. The website is up here. It's bcc.mywconline.net, N-E-T. All right. When it's your first time coming in, you just click right here where it says register for an account. The first time is the hardest. After that, to log in, you simply just write your email, write your password, and choose what it is you're looking for, right? If you're looking for in-person tutoring, it's that link. I believe last time I wasn't able to show you this, right? In-person tutoring would be that link. Online would be that link. Then you log in, make your appointment with whoever you want, and that's it. The nice thing about your class, everybody could help you, all right? So if you guys wanna see me, you can, but you're not limited to just me. Just in case our schedules don't align, that could happen. Mm-hmm. I got you. So it's bcc.mywconline.net. All right. I'm also going to post it in the announcement, by the way. Like every time I always post it in the announcement, so you can get it from there as well. All right. Homework 2 has been posted in case you guys want to take a look at it. Some of you might know today's lesson already. You might want to knock out the homework in the middle of class. That's fine. I'm not mad at you. I get it. All right. Today we're going to be doing fractions. We're going to be adding them, subtracting them, multiplying them, dividing them. That's the whole lesson. So if you're bored, do your homework. It's all good. I get it. So I showed y'all that. Let me stop sharing real quick. Here. Good. All right. Before I even move on, though, is any questions though? Any concerns?
You get the question wrong. Is it like
Nah. You could try the question as many times as you want, man. All I care about you doing all your homework is you get 100. right? But if you want to try it 50 times before you get the 100, I'm cool. You know, just give me 100. That's all I want. All right? I mean, just keep going until you get it. You know. So yeah, it's all right. I get it. It took me a long time to get as good as I am now. You know, it's a lot of practice. I feel you. I feel you. Yeah. I mean, you know what? It might surprise you. Like people is older than they look. You know? Yeah. Yeah. Like I know y'all might look at me and be like, "Oh, he young." Like, nah, I'm type old. Like don't. I got like 3 gray hairs, you know. Like, yeah. So yeah, so try your homework. No penalty for doing the question more than once. All I want you to do is just get it right. You know, it's okay if you can't get it all right by yourself. You can go to tutoring and get it all right. Just make sure that when you go to tutoring, you understand, you know, like what it is, right? Because we do have tests coming up, right? And we want to be able to do our test, you know. So make sure you understand what you're doing in tutoring. Don't just have them just do all the questions for you, you know. Yeah. I mean, some new tutors will. I won't do that, but some new tutors will do that. Mhm. I can tell you though, as a tutor, it is a little frustrating when I get a student that asks me to do that because like of time, right? Something that you're gonna notice when you guys make the appointments, right? Um, Sometimes it's not just you making an appointment. There might be 2 other students along with you for that hour, right? So if I'm split between 3 people, and let's assume that those 3 people are different, right? 3 different classes, right? I can't spend the whole hour just helping you, you know, like I can show you how to do one and you knock out your homework. Then I'm gonna do that to the next person, the next person. And that's the hour right there. You know, so sometimes just know that sometimes that could happen. It didn't happen today because today is the first day, you know, so there's hardly any students. But in the future, if you go there, like our times might be split, you know. So in the event that that happens, you want to be able to learn the process and then be able to knock out your homework after that. And to be honest with you, you have a bunch of questions for homework, but they all follow 1 or 2 simple processes. You just got to repeat it again and again and again till it gets boring. You know, then you're good to go. You know? All right, so let's jump into our topic for today. This is gonna be fun. We're talking about fractions. All right. And again, if you know fractions, go do your homework. No problem. All right. So first thing we want to talk about simplifying fractions. All right. So a fraction is a way to represent parts of a whole. The fraction 2/3 represents 2 of 3 equal parts, right? As you can see in this figure. So in the fraction 2/3, the 2 is called the numerator and the 3 is called the denominator, right? And the line is called the fraction bar, right? So let's pretend that this is like a pizza, right? So that's the hole right there. And then we're trying to show what 2/3 looks like, right? So we have the 2 shaded regions right here. That's the 2. And then the 3 would be the total of everything. That's 2/3, right? So in the circle, 2/3 of the circle is shaded. So the 2 of the 3 equal parts. That's what this means. All right. So that being said, let's talk about what a fraction is. Let's talk about what a fraction is. And this is being recorded, by the way, so if you miss something or whatever, like you can always go back. But don't hesitate to ask me either if you want me to repeat something, that's fine. All right, so fraction, right? A fraction is written as A over B, where B cannot equal 0, right? It's illegal to divide by 0, so our denominators cannot be 0, right? And A is the numerator, B is a denominator. A fraction represents parts of a whole. The denominator B is the number of equal parts the whole has been divided into. And the numerator A indicates how many parts are included, all right? So that's our basic definition. That's what a fraction is, all right? Let's keep going. All right. So fractions that have the same value are called equivalent fractions. The equivalent fractions property allows us to find equivalent fractions and also simplify fractions. All right. So let's take a look at that property real quick. This is going to be real cool. It's going to be real cool. Hey, how are you doing? Welcome, welcome. It's great to see everybody in person. All right, so we're going to talk about the equivalent fractions property. So if A, B, and C are numbers where B cannot equal 0, C cannot equal 0, then A over B is equal to A times C divided by B times C, and the reverse, A times C over B times C is equal to A over B, right? So they're both equal, vice versa, right? Equivalent fractions property. Good stuff, good stuff, good stuff. So let's talk about this just a little bit more. Just a little bit more. All right. So a fraction is considered simplified if there are no common factors other than 1 in its numerator and denominator. So for example, 2 over 3 is simplified because there are no common factors of 2 and 3. However, 10 over 15 is not simplified because 5 is a common factor of 10 and 15. Make sense? So we simplify or reduce a fraction by removing the common factors of the numerator and the denominator. So a fraction is not simplified until all common factors have been removed. If an expression has fractions, it is not completely simplified until the fractions are simplified. All right? So sometimes it may not be easy to find common factors of the numerator and denominator. When this happens, a good idea is to factor the numerator and denominator into its prime numbers, right? This is the trick. Then divide out the common factors using the equal fractions property, all right? So we're gonna take a look at that. We're gonna take a look at that. You guys are gonna see that in play right now. So let's say, for example, I want to simplify this. Negative 315 divided by 770. All right. I'll be honest with y'all. I don't know my timetables as well as you guys do, right? I'll be struggling over here, right? So what I gotta do is I gotta factor this into its basic prime numbers that I can do. And then I'm gonna just cross out the primes that are alike. And then that's it. So let me show y'all. Let me show y'all real quick. There's a trick I like to use called the prime factorization tree. I don't know if you guys ever heard of that before, but I'm gonna show you it real quick. I'm gonna start off with the 315. All right. Now it's 315, right? I need two numbers that when I multiply it will give me 315. The easiest number that I could pick is something times 5. I don't know what that is though. That's 315. So I'm gonna just divide that out real quick. And yeah, I still do division like this, you know. Times is hard right now. So let me see, 25, 30, that's 6, right? I know, don't judge me. I still do this, right? 5 goes in, that's 3. 5 times 3 is 15. We good, boom. So that's 63. Bam, right? I could keep going with that though, right? I think I could break this into what? 21 and 3, maybe? Right? 5 is a prime number, 3 is a prime number, 21 can still get broken down. I think that's 7 times 3, right? Bam. So what did I just do there? I broke down 315 to become negative. I'm gonna just do this in order. 3 times 3 times 5 times 7. Right? If I multiply those 4 numbers together, I get back 315. I'm gonna do the same thing with the 770, right? So let's take a look at that. 770, right? Now, I don't know about y'all, but 770 ends in 0. So I already know that's divisible by 10, right? Just make my life easy, right? So I'm gonna just put 10 right here. I'm gonna put 77 right here, right? Now 10, you already know 10 is breaking down into what? 2 times 5, right? Those are prime. 77 is gonna get broken down into what? 7 times 11. Those are prime, right? So now just write it all out, right? So I'm gonna write down 2 times 5 times 7 times 11. Just like that, right? Let me get a different color for this now. I'm gonna do pink, all right? So now what I'm trying to do, I'm just gonna knock off the numbers on the top and the bottom that are the same. That's simple, right? I got a 5 up top, so I'm gonna knock off the 5 on the bottom. I got a 7 up top, I'm gonna knock off the 7 on the bottom. That's it. Nothing else is the same, right? So after that, multiply what you have back together. This becomes negative 3 times 3. What's that? Like 9? And then 22. And that's my answer. I'm done. That's a simplified version of it. Right? So that's how I do it. Now I'm doing it by hand. Y'all got calculators, so it shouldn't take y'all that long. Yeah. Remember the one I told y'all last week, TI 36X Pro? You guys could get that calculator to help you out with this. Okay. I'm sorry? That's good. Yeah. For the 84, I could tell y'all to get that calculator, but it costs mad money. No, it's Apple. You know, it's better to use the calculator though, man. Because like in other classes, they're not gonna let you use your phone. So just to keep that with that consistency, you know. With it, you can use the calculator on the test. Yeah. And then I have like a little cheat sheet, formula sheet that I'm gonna give y'all. That's gonna help you with everything as well. Man. So yeah, so y'all gonna get through this. Y'all gonna get through this. But you know, like when I'm teaching y'all, I'm gonna try and do it by hand. You know, just cause like I don't got no calculator, so I'm gonna just show y'all the old school tricks how we get through this. But yeah, on your calculator, you could play around with the numbers till you get this, you know, but this is my way. I just break it down to them prime factors. So that being said, it's a little bit easier, but you guys try. I mean, my numbers was crazy, you know. This not too bad, right? I don't know how many of y'all like peep my little trick. I look at that last digit, and then that's how I really come up with what I'm gonna divide it by. You know? That's 69. So what number jumps into your head to divide it by? Exactly. You good? Yeah, I got questions like this on the homework, so don't worry.
So basically, you ask people like 3 times what equals 69.
Yeah. Or just take 69 divided by 3 and whatever's left over, you already know.
Oh, my.
Yeah. I mean, that whole tree thing, like, that's just like, that's my way of doing it. If y'all, is the tree is confusing? All right. I mean, if the tree is confusing and you have another way of doing it, then, please go ahead. 23 is prime, yeah. Yeah. And remember, prime is a number that's divisible by 1 in itself only, so that's as deep as it could go, And then you just cross out the like terms and that's it. What you think? How you doing? You lost?
Yeah, I'm letting you do this.
All right.
Again, this is the easy part.
Nah, this the hard part.
Really?
Yeah.
That's good.
Rest of the class is easy. That's the hard part. Adding and subtracting and all that. Yeah. I mean, I'll be honest with y'all. I still count my fingers and everything. I'll be up in the supermarket like 1, 2. Like, is this really a sale? You'd be surprised how many people don't know this stuff, though. Yeah. Let me tell you, there was this restaurant chain. Hello. I don't remember the name of it though. But long story short, it went out of business. Right. So they had the audacity to try and compete with McDonald's. You believe that? Right. So McDonald's came out with the quarter pounder burger, right? Y'all know the quarter pounder, right? Quarter pounder is just a 1/4 of a pound burger, right? All right. This restaurant came out with a 1/3 burger, right? So so it's 1/3 of a pound, right? Now y'all know that 1/3 is bigger than a quarter, right? Like if you do the math on it, 1 divided by 4 is 0.25, right? 1 divided by 3, 0.33. 33 is bigger than 25, right? So that's a bigger burger, but people when they saw the marketing of it, because they write it in words, they don't write it in numbers, right? They say, yo, quarter pounder, that's more than a third burger. So this company went out of business and they was giving out more product. You believe that? Go ahead.
Hey, what you do after you got all the problems?
Just knock out the like terms, right? And whatever's left over, just multiply them. Yeah, and then that's it. Yeah. Not adding, multiplying them. Yeah, they all get multiplied together. Yeah, see, y'all want to see the example before. See, I'm just putting them together like that. You don't got to put them in order from smallest to largest. Like I just did that because I thought it looked pretty. But if you guys want to jumble it up and do it, like that's fine. It'll still work. Just crossing out what's alike, All right, let's take a look then. Let's take a look. I don't even know how to do this. I'll be honest, right? Let's start this off, right? So I gotta start off with that 69, right? Gotta break that up. Now you said 3, right? I agree with you. And you got 23, right? All right. So then we good to go. It's the hard part right here now. We got this 120, right? What am I gonna divide that by? 12 and 10, right? All right. So that's 0, you already know. And then the 10, what's that, like 2 and 5? You got 6 and 2? All right, I'm good with that. And then keep going. What's the 6? 2 and 3. Now we're talking, right? So then now just put it all together. Can I fit this? I'm gonna try it. Hold up. Let me see. I'm gonna try it. So it's gonna be negative, right? On the top, I got 3 times 23. Hold on, let me just move this little green box right here. Are we good? And then on the bottom, it's gonna be
3, 2, 3, and 5.
yeah, so 2 times 2 times 2 times 3 times 5. Yeah, we good, we good. Let me just change my color real quick. All right. So what I'm looking to do is I want to cross out the like terms. So I got a 3 up top here. I'm gonna cross out a 3 down here. That's it. Right? And just multiply straight across, and that's your answer to the whole thing. So what do I have? I have negative 23 over, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 5, what's that? 25, 30, 35, 40, right? So then that's it. It's that simple. Questions on that? That makes sense? Y'all want to see another one? Or y'all good? It's another one? Dang, this next one's is even easier because y'all already know what's going to happen here. Yeah, that's not too bad right there. I mean, low key, you could just copy half of it is right there. All you gotta do is the other half. Look at this machine in the back. This look like one of them rooms where they look at X-rays and stuff. That's cool. So the ones that are similar, just knock them out and just multiply everything back together to get the final answer. So like when y'all doing your homework, they don't want the factors, they want the when you combine them all together, you know, what's left over. That's what they're looking for. And again, no penalty for trying your homework, you know, nothing wrong with that. Let's take a look. Now, since I know part of this answer, I'm just gonna copy. So this is 2 times 2 times 2 times 3 times 5 for the top. And then I'm just gonna do the tree for the bottom. I forgot the negative sign. Forgot the negative sign. All right, so let's do that tree on the bottom. So I got 192. It ends in 2, so for me, I'm just thinking I'm gonna cut this in half, right? So this is gonna be what, 2 times, what's this, like 81? 86? 96? Okay. All right,
I got a question.
go ahead.
What did you do about other numbers?
That's fine. Yeah, like you wanna do it by 4 or something? Yeah,
I did 24.
that's fine too. Yeah. It will all work out because it's gonna be the same prime numbers at the end, you know? All right, so I heard 96, so let's break that down. What's that gonna be? 48 and 2, very good. And then 48, what is that? 24 and 2, very good. Like that. What's 24? 12 and 2, very good. What's 12? 6 and 2, very good. And then what's 6? 3 and 2, very good. Let me just count real quick. 1, 2, 3, 4, 5, 6. Okay. I have 6 2s. 1, 2, 3, 4, 5, 6, and a 3. Am I correct? Yep. All right. All I want to do now, just change my color real quick. I want to cross out my like terms, right? I have 1, 2 up top. I'm gonna cross out 1, 2 on the bottom. 1, 2 up top, 1 on the bottom. 1, 2 up top, 1 on the bottom. I have a 3 up here. I'm gonna cross out 3 here, and that's all I'm left with, right? So whatever I'm left with, just multiply it together, top and bottom. So instead of the negative, up top is just 5, so 5 comes down. On the bottom, I have 2 times 2 times 2, which is like what, 8? Right? 2 times 2, 4. 4 times 2, 8. That's my final answer. Negative 5 over 8. Wait a minute. Okay. Questions on that? Make sense? All right. Huh? Say it again? Yeah, it always work out. So just to recap real quick, I want to give y'all the procedure one more time. I know some people like to see it written out, so this is for y'all. All right, so how to simplify a fraction. Step 1, rewrite the numerator and denominator to show the common factors. If needed, factor the numerator and denominator to prime numbers first. Step 2, simplify using the equivalent fractions property by dividing out the common factors. That's the slashing of the top and the bottom. Step 3, multiply the remaining factors, get back to the answer. That's it. That's some notes for you guys. All right, now that we're done with the hard stuff, let's get to the easy stuff. All right. So we're going to be multiplying and dividing fractions. All right. So many people find multiplying and dividing fractions easier than adding and subtracting fractions. It is. To multiply fractions, we multiply the numerator and multiply the denominators. That's it. Real nice and simple. Nothing crazy here.
One of the questions together.
Which one? From last week or this week?
Question.
All right, we'll take a look at that. After I put up the next example, I'll take a look.
Yeah.
Which Yeah. And there's no penalty for doing a question multiple times. So, yeah, got you. Yeah. All right, so fraction multiplication right here, right? If A, B, C, and D are numbers where B does not equal 0 and D does not equal 0, because it's illegal to divide by 0, right? Then A over B times C over D is equal to A times C divided by B times D. So to multiply fractions, you multiply the numerators and you multiply the denominators. All right, long story short, if I have a fraction here, I don't care what number it wants to be, right? You multiply straight across. Think of it like that. Just multiply straight across. That's all I'm saying. No matter what the number is, multiply straight across. All right. Let's take a look. Oh, wait, you know what? I forgot to say something. Let me just make a comment real quick before we look at an example real quick. All right. So when multiplying fractions, the properties of positive and negative numbers still apply. Of course, it is a good idea to determine the sign of the product as the first step, right? And then in the next example, we'll multiply a negative by a negative, so the product will be positive. When multiplying a fraction by an integer is like a whole number, right? It may be helpful to write the integer as a fraction. Any integer, a, so for any number, can be written as a over 1. So for example, 3 is the same thing as saying 3 over 1, right? That's going to help us in the future. I wanted to make that comment real quick before we look at our example.
So, what about 9 the same thing, right?
So 9 over 3, right? That would reduce down to 3 over 1. All right, let's take a look real quick. So I want to multiply negative 12 over 5 times negative 20x, right? I want to multiply those together. So now notice that negative 20, right? It's a whole number, right? I'm going to write that over 1. So this is going to become what? Negative 12 over 5. Oops, so you know what? I shouldn't use an x. Times negative 20x over 1, right? So I'm putting the whole number over 1. And then after that, what I want to do, just multiply straight across. Numerator with numerator, denominator with denominator, right? So, real quick, going straight across. Negative 12. Well, let me start off step by step. Negative times a negative is a positive, right? So then now 12 times 20, what's that? 240, right? With the x, right? So 240x over, now check this in the calculator. I always get this wrong. What's 5 times 1? All right, good. Thank you. I need help, man. My multiplication not so strong, right? So now I got 240x over 5. But I'm not done though, right? Because I could still factor this out a little bit, right? 5 could go into 240. 5 goes into 240 how many times? Say it again. 48 times? Okay. Taking your word for it. It's 48, all right. So this is going to become what? Final answer? 48x over 1 or 48x. And that's it. So you multiply straight across, then you reduce it, and that's your final answer at the end. That's all it is. All right. Questions on that? Good? All right, you guys try. I'll give y'all one real quick. A little bit easier, but still a good question. And you do it the same way. We good? All right, let's take a look. So first thing I want to do is I want to rewrite this, right? So this is going to become, hold on. Let's change my color a little bit. 11/3 times, we're going to have the negative 9a over 1, all right? All right, so help me out. A positive times a negative is a negative, okay. All right, now 11 times 9a is what? 99a, very good. Over, what's 3 times 1? 3, awesome. Let's reduce this now, right? So 3 goes into 99, how many times? 33 times, right? So this is going to become negative 33a over 1, or just call it a negative 33a. And then that's it. Questions on that? It is? All right, I told you. First one is the hardest one. Yeah. Last week was even harder than the first one. Hmm? You got last week? I thought last week was mad hard. Y'all want to see another one, or y'all feel like this is good? Another one? Y'all can check it out. You're doing welcome. This is 204. Yep, this is it. You're welcome. All right, let's take a look. So I got a 13/7 times a negative 14/b, right? So I'm gonna keep that 13/7. I'm gonna write that negative 14b over 1, right? Because that's a whole integer right there. All right, welcome, welcome. Now, help me out. Positive times a negative is a what? Negative, good. All right, so I got a 182, I guess, times B over 7. And then 7 goes into 182, how many times? 26 times, so negative 26B. Yep, that's good. Questions on that? Good, awesome. All right, let's take it up a notch. I'm gonna throw a new vocabulary word at y'all real quick. So now that we know how to multiply fractions, we are almost ready to divide. But before we can do that, we need some vocabulary. The reciprocal of a fraction is found by inverting the fraction, placing the numerator in the denominator and the denominator in the numerator. For example, the reciprocal of 2 over 3 is 3 over 2. Flip it, right? Since 4 is written in fraction form as 4 over 1, the reciprocal of 4 is 1 over 4. So to divide fractions, we multiply the first fraction by the reciprocal of the second, right? Keep, change, flip, that thing. All right? Let's take a look real quick. Let me show you what I'm talking about. All right? Talking about fraction division right here. So if A, B, C, and D are numbers where B cannot equal 0, C cannot equal 0, and D cannot equal 0, then A over B divided by C over D is equal to A over B times D over C, all right? So to divide fractions, we multiply the first fraction, A over B, times the reciprocal of the second, which would be the D over C. All right. So by the way, on the cheat sheet, formula sheet that I'm going to give you, like this is what I'm giving you right here, right? This formula stuff. So you can answer any question. All right? Yeah, you can use it on the test. All right, so we need to say B cannot equal 0, C cannot equal 0, and D cannot equal 0. Be sure we don't divide by 0, right? Because it is illegal to divide by 0. All right? Just letting y'all know that. So in the bottom number. So for example, I can't say 7 over 0. I can say 0 over 7, but I can't say 7 over 0. Okay. All right, let's take a look at an example. Let's see what we're really talking about here. All right. So I want to find the quotient of negative 7 over 18 divided by negative 14 over 27, right? So what am I going to do first, right? I'm going to keep the first fraction that I have there, right? So this is going to be the negative 7 over 18. I'm going to change that division sign to multiplication. Because these are numbers, I'm going to use the x multiplication for this, right? And then I want to flip the second term right there. So this is going to be a negative 27 over 14, just like that. Just like that. And then after that, just multiply straight across the way you know how to do. All right? So this is going to become, right? A negative times a negative is a positive, right? So this is just what? 7 times 27. You guys are right. Over 18 times 14. I'm just gonna make my life easy. 7 goes into 7 once, 7 going to 14 two times. And I think 9 goes into 18 twice, and 9 goes into 27 three times, something like that. Multiply straight across. 1 times 3 is 3, 2 times 2, 4. And then that's my answer. So if you're wondering what I did there, right? What I did was I reduced it first before I multiplied. Truthfully speaking, this is how I actually do my multiplication fractions because I don't know my multiplication tables like you guys do. But I have to use tricky things like this. Right? I'll be honest, that's how I do it. Right? But if you did 7 times 27 divided by 18 times 14 and then factored it out and all that, I'm happy. That was the right thing to do as well. I'm just bad at multiplication, so I gotta do tricks like this. Right? You got right, you gotta reduce it. You know? But you see how bad I'm at with that. Like I gotta do a whole tree and whatnot. I'll be struggling over here, man. I mean, the only reason I'm standing at this podium is so y'all can't see me count my toes. I'm over here doing that as well. All right, you guys try. Thanks. I just realized like y'all don't get to see club hours on Thursday. Man. Oh. From 12 to 2, yeah. I mean, we chill, eat food, talk about whatever topic the club is about. Yeah. I don't know. Sometimes they be having music and stuff on campus. Sometimes there be some crazy stuff on at club hours. One time they had a whole mariachi band up in here. Like I don't know why, but they just did it. Yeah, that happens sometimes. Yeah, that happens from time to time. Alright.
So here, like, I don't know what to do. If they go there, like exit out all the smaller numbers, I don't know what to do with that.
You could do the same thing too, right? Cause like,
I could just use any number.
oh, 7 and 35, right? You can reduce those a little bit.
So it's, right,
So like 7 goes into 1, so 7 goes into 35 on the inside. One, yeah. 7 goes into 35 on the inside.
multiplication.
It's 5. And you can do the same thing with the 27,
So
37.
it's just, it's small numbers, it's just how many times the number can go into itself.
Exactly.
Maybe.
Maybe I'll show you a different technique also. All right, let's take a look at this one real quick, right? So remember, I want to keep that first term right there, right? So I have -7 over 27. I'm gonna change that division to multiplication. Because these are numbers, I'm gonna use the x multiplication, right? And I want to flip the other one, right? So this is gonna be -36 over 35. Now, a negative times a negative is a positive, right? So I'm gonna do something a little bit different over here, right? I'm just gonna factor these and write down the factors right here, right? So I have the 7 right here times 36 is what? I think that's like 2 times 2 times 3 times 3, right? I'm just breaking it up. We know it's 6 times 6, and 6 is 3 times 2, 3 times 3, right? You could do the same thing on the bottom, right? 27, what's that? 9 times 3. So that's just 3 times 3 times 3, right? 35 is what? 7 times 5. Just like that, right? Cross out the like terms, right? Cross out the like terms. So 3 right here, 3 right here, 3 right here, 3 right here, 7 right here, 7 right here. And then that's it. And so what are we left with? 2 times 2, 4 over 3 times 5, 15. That's another way you could do it, right? Break them all individually into their prime factors, write them straight across and cross out the like terms. That's another technique that you can use to do this as well, right? Or multiply it all out, then reduce it at the end as well. Just trying to like give you guys options, trying to make it as simple as possible, you know? Y'all want another one or y'all feel good? Another one? All right, try that out. Whatever technique works for you, use it. No pressure. All right, let's take a look. Remember what I want to do? I want to keep that first one, right? So this is going to be a negative 5/14. I'm going to change that division to multiplication. And then I want to flip the other term. So this becomes negative 28/15. And then a negative times a negative is a positive, right? And then how we want to do this?
Five times, five times, times, two.
Okay, times 7 times 2 times 2. I like that. All right, over. Very good. That was excellent. That was well done. And then just cross out the like terms, right? 7, 7, 5, 5, 2, 2. What am I left with? 2/3. That's it. The extra stuff. So we know that 28 is what? That's like what? 4 times 7. And then the 4 could get broken out into just 2 times 2. So that's where the 2 to 7 came from. Exactly. And the 14, you already know that's 7 and 2. And then the 15, you already know that's 3 and 5. So it's just putting them all together like that. And then crossing out the like terms. Yeah. Sometimes it's easier to just kind of keep them separate and break them down like little by like that and just put them all together multiplication wise and then knock out the like terms. Yeah. It's just a technique, you know, if you want to do it the other way, multiply everything else out and then simplify, go right ahead, you'll still get the right answer. You know, I'm just being lazy because I'm not that good at multiplication like y'all. You know? All right. Let's get to the easier stuff. So we about to do adding and subtracting fractions. All right. So when we multiplied fractions, we just multiplied the numerators and denominators. Excuse me. We just multiplied the numerators and multiplied the denominators right straight across. To add or subtract fractions, they must have a common denominator, right? So they gotta have the same denominator in order to add or subtract. Right? I'm sorry? For multiplication. But for adding and subtraction, we gotta get the same denominator first, and then we can add or subtract. Yeah, go ahead. Yeah. You don't want to leave it on the floor, you can put it on there. Yeah. You're welcome. Let's give you the formula real quick. So fraction, addition, and subtraction. If A, B, and C are numbers where C cannot equal 0, then A over C plus B over C is equal to A plus B over C. And A over C minus B over C is equal to A minus B over C. So to add or subtract fractions, add or subtract the numerators and place the result over the common denominator. That's it. Right? That's the secret right there. I just want to make a comment before we look at an example real quick. I'm sure y'all heard this before. The least common denominator, LCD, of two fractions is the smallest number that can be used as a common denominator of the fractions. The LCD of two fractions is the least common multiple of their denominators. All right? It's giving y'all some vocabulary. No, somebody got to hear that definition again, so I got you. All right? So the least common denominator, right? The LCD of two fractions is the least common multiple of their denominators. That's the formal definition right there. So one last comment. So after we find the least common denominator of two fractions, we convert the fractions to equivalent fractions with the LCD. Putting these steps together allows us to add or subtract fractions because their denominators will be the same. All right. So let's take a look. So I have 7 over 12 plus 5 over 18. That's what I'm going to do. So I'm gonna be honest, I'm really bad at this too, all right? So here's my trick on how I do this, all right? We already know this is 12, right? What's the prime factors of 12? 6. All right, so 6 times 2, right? So that's gonna be 2 times 2 times 3, right? Am I right about that? 3, 6, 12, yep. And then 18. 6 and 3, right? So this is gonna be, I'm trying to do this in my head. 2 times 3 times 3, right? Yeah. All right, so we good, right? All I did was just break it down to our prime factor, same thing that we did before, right? To find the LCD, let me show y'all how we do the LCD. Well, this is my technique of doing the LCD because I'm not as good as math as you guys are, right? I pick one of these numbers. It don't matter which one. It could be the 12 or the 18, right? I'm gonna do the 12 just because that one's on top, right? So we already know what 12 is. 12 is 2 times 2 times 3, right? Just choosing the 12. And now I'm gonna look at the 18, right? And I want to count how many numbers they have in common, right? So let's see. I have 1, 2, and I have 1, 3 in both of them, right? So we have these in common right here. This is in common and this is in common, right? So I don't need to repeat the commonalities, right? I just need the extra. 18 got 2 3s in it, right? And my LCD only got 1 3, so I gotta throw that extra 3 up in there. Boom. So that's it. That's my LCD. 2 times 2 times 3 times 3. Put that together. What's that? 4 times 9. And what's that? 36? All right. You lost? Because they're there already. Right? So what I'm trying to do is I'm trying to find a number that 12 and 18 can go into, right? And that number, the smallest number that would be is actually 36. This is by process of trying to figure it out when I don't know how to figure out 36. You know, go ahead.
But you'll also multiply the numerator as well.
No, so let me show you what's gonna happen. Let me show you what's gonna happen right here.
The coders fly.
I got you. I'm gonna show you what's gonna happen, right? So I got this 7 over 12 right here. All right? And I got this 5 over 18 right here, right? Now, I found that the LCD is 36, right? I want to make that 12 into a 36. What do I have to multiply that 12 by to make it 36? By what? By 3, right? All I gotta do is multiply this by 3 to get 36. But what I do to the bottom, I gotta do to the top, right? All right, I got that 18 right there, right? And I want to make the 18 into 36. What do I have to multiply that by? By 2, right? So multiply this 18 by 2. But what I do to the bottom, I do to the top, right? Bam, just like that, just like that. So now what do I have? 7 times 3, what's that? So 21 over 36 plus 5 times 2, 10 over 36. Now I want you to notice though, right? I got the same denominator now. So all I gotta do is just add the top, right? 21 plus 10, what's that? 31. So 31 over 36. That's my final answer. That's it. All right. Questions on that? You don't got to do this prime thing if you could look at it and be like, oh yeah, 36. Like if you got that eyesight, go ahead. You know, I just be struggling with my numbers and stuff. You know, I still count my fingers and everything.
So
So
like you doing the LCD, right?
yeah.
How do you know when to stop? What do you just point 2 and 3?
So first off, you grabbing one of the denominators, right? In its totality, everything, right? And then you just put in whatever is missing from there into it. So for example, right, the 12 got 2 2s and it got 1 3, right? 2 2s and 1 3. The 18 got 1 2, but it got 2 3s, right? So the LCD has to have a little bit of both, right? So it has to have the 2 2s and it has to have 2 3s as well, right? And that's it. Mhm. You could. Mhm. I'm trying to give y'all the easiest way. There is another way to do this that's more complicated. I mean, all of them work. So another way that you could have done this, you could have found, instead of the LCD, you could have found the CD, a common denominator. The common denominator would have simply just been to take the 12 and the 18 and multiply them together and call it a day. You could do that, right? And then what you do to the bottom, you do to the top. Yeah, you could do that. That's legal and it'll work. But at the end, you gotta reduce it down, right? Because the final answer is not that big number. It's the 31 over 36. So you gotta reduce it down to come back to that. That's legal too. I give you full credit for that as well if you wanted to do that.
The top by the same.
Exactly. Yeah. And so that same process, what you do to the bottom, you do to the top. That doesn't change. Yeah. All right, you guys try. So if you want to find the LCD, go ahead. If you want to find the CD, go ahead. If it was me, I would like to do the LCD because I don't know how to reduce as good as y'all, but, you know, I gotta be doing trees and stuff. You know, it just occurred to me we got class on election day. Oh man. I mean, well, we got time after class though. It ends at 5 and election closes at like 9 or something. So, yeah. I think so. Yeah, you register here. Yeah. If y'all are interested, they got this website. It's called who'sontheballot.org. Right? Who'sontheballot.org. Y'all could go on there and just type in your home address, right, into it. And it gives you your official ballot for where you live. And then you'll know who's running. It even links their Facebook and their Instagrams and all that in case you want to do a little research on them. you know? Oh, yeah, for sure. I got you. Got you. By the way, I know we don't have class on Wednesdays, but I hope y'all taking advantage of the ARC Resource Center. Y'all taking advantage of pantry and all that, you know?
What's that?
Free food, yeah, like free groceries. Yeah, yeah. It's up in Low Hall. Y'all just go there. Yo, but don't underestimate it though. Like bring a cart, like no bullshit. Like bring a cart, you know, like yeah, like especially when it's Thanksgiving, like bring a cart. If you have a car, that's even better. You know, like yeah.
All I gotta do is show me a little ID.
That's it. Show up your ID, like yeah.
No, it's not. You have to sign up for it.
Yeah, you sign up and then you go get it.
You have to, they have to put you in, and it's a process. You just can't just walk in there.
Yeah, but sign up is not bad. I'll show y'all at the end of class. The sign up is like
You just sign up in the phone, it's like, well, you have to do this, it's a lot.
what else you had to do?
Not only just to sign up, she has to record it and give you a picture.
Yeah,
And I think the call coming back, she has to ask you to.
that's because I don't think it's this week. I think it's next week. That's why.
Look like all of it.
Yeah.
She has to respond in cities.
Yeah. All you need to know is that they're gonna send out a mass email like come pick them up, and then you just show up. And that's it. You know? Yeah. You know, they like, and this ain't like no normal pantry either. Like, you know, normal pantries, you go there and you be getting like food and stuff. No, they got some stuff that don't even make sense. Toilet paper, toothbrushes, deodorant. Like what they have to do with food? Yeah, like nah, bro, you really can't carry it. I'm telling you, like, bro. Yo, bring a cart, man. Like I'm telling you, bring that cart. The struggle is real. I'll be seeing people with, like calling taxis and stuff, Uber and stuff, because like, yo, it's more than what you like. I'm not even communicating it correctly. You know, like it's more than what you think. You know, like I'm trying, but I know I'm not hitting the top ends. You know. Yeah. I mean, they got more stuff that they be giving out on campus too. Like today, I got what they call these again? Pop sockets or whatever. Yeah, I got a BCC one today. Yeah, they had them in Meister Hall earlier. Yeah. They always got stuff on campus. So yeah, that's all you gotta do. But yo, you see Thursday though? Oh, that's what y'all missing out. Thursday, 12 and 2. Be lit. Mad lit on campus. All right, real quick. So we got 12 right here, right? I'm gonna break that down to the prime factor. So that's like 2 times, let me think about that. 6 times 2, yep. So 2 times 2 times 3. That's true. Yeah. And then 15, I think, is like what, 3 and 5? All right. So that's it. So all we got to do is just pick one. It don't matter which one. You pick the 12, pick the 15, right? I'm going to pick the 12, right? So for LCD, I'm just copying the 12. The 12 is what? 2 times 2 times 3. Now, when I look at the 15, right? The 12 got 1, 3. The 15 got 1, 3. So I don't got to repeat that 3, right? But the 15 got a 5, and I ain't got a 5 in my LCD. Put that 5 down there. And that's it. That's the LCD right there. 2 times 2 times 3 times 5.
So you just move all the numbers that's there, but you just
Exactly. But no repeats. That's a trick. Because the 12 got 2 2s. See, if I had another 2 in the 15, then I wouldn't write that in the LCD. I'd only write one of them, you know?
Oh, so the 15 had a 2, you would only write 1 2.
Exactly. No repeats. All right. So that's the trick right there.
So the 12 had
5, you wouldn't put 5.
I would have had just one 5 in there. Like say the 12 had 2 5s, right? Just for conversation reasons, right? And then the 15 got a 5. I'm only gonna write down. So I'm gonna write down 2 5s, and then that's it. Right? But I'm not gonna write down 3 5s. You know? So that's the trick right there. So let's multiply this out real quick. What's that? 2 times 2 is 4. And then what's this? 3 and 5 is what, 15? So what's that? Like 15, 15, 30, call that 60. That's my LCD, right? Yes, you could have multiplied the 12 times the 15. It'll all work out. Yeah, come through, man. Come through. Yeah. So real quick, I want to make that 12 into a 60. What do I have to multiply that by? Excuse me. By 5, right? But what I do to the bottom, I do to the top. I want to make that 15 into 60, right? So I'm gonna multiply that by 4. What I do to the bottom, I do to the top. All right. After that, we just do the multiplication. 7 times 5, what's that? 35 over 60. Plus, what's this? 44 over 60. And after that, you just want to add it straight across, right? 5 plus 4, what's that? Like 9. And 3 plus 4, what's that? Like 6, 7. So 79 over 60. And then that's it. All right. Questions on that? Good. All right. Got you. Y'all need to see another one, or y'all good? Go ahead. Hmm? Got you. Now you talk about changing to a mixed number. That's fine too. I would take either one. So you guys try. What happened? Not you. The homework is simple. It's not that bad. Yeah. I know it's like mad questions, but yeah. But you're gonna see though, with this class though, like because we in like the basics right now, the homework be like large, right? But as the class goes on, it's just gonna get smaller and smaller and smaller. Eventually, y'all gonna have homeworks where it'd be like 2 questions. You know, y'all probably finish it before y'all walk out the door. It'd be like that. But that's when we get to the easy stuff, you know? Yeah. Oh yeah, this class gets easy as it goes on. Yeah. Wait till y'all see trigonometry. Trigonometry's light. You know? Well, for oh man. I feel you. Nah, trigonometry not that bad. I mean, y'all might need it for y'all major though. You know, everybody here is doing engineering, right?
Hell no.
Nah,
You know, radiology.
radiology. Also, you know about that machine right there. Then that's all. Yeah, that's dope. Radiology is dope, man. Y'all make good money. Yeah. Ain't nobody doing automotive tech. That's fire. Yeah, you do. Yeah. Yeah. Yeah, you can't.
I don't think so. Some people cannot. He did this. He ain't that smart. He ain't smart. So in other words, he pays him to do that. Pretty much, okay.
I mean, yeah. That's the definition of a boss right there, right? Delegate the work. Mhm. I don't know, like what I would say about Trump, like I'm not gonna say that he's an idiot completely. I feel like he's there's topics, there's things that he knows, that he knows, and then there's other things that he doesn't know. You know, like, I'll just say it like that.
This is a mess, this is a.
Mhm. His daddy now. That's a genius. You like that? Easy, right?
Some of them, some of them.
Nobody doing biology, no chemistry, none of that. That's dope, man. I like biology. That's dope major.
And you know, I don't think.
What's that?
You just don't, we gotta take regions no more.
They took away the regions?
Oh, yeah, you gotta take regions no more.
Yo, that was the struggle. That was the struggle. Nah, when AI gets like really good, like yeah. Yeah.
You're gonna make you go for your major, you know.
Right?
I wish that's how it was.
I mean, some majors they probably don't even push on the internet. You know, like low key, you could get a computer science degree on the internet.
I mean, yeah, but it's just gotta like be like competitive. So it's
Yeah.
like, absolutely.
Automotive tech, like you don't still have to come here, you know, fix the car and all that. Nah, but y'all know what the hardest major is here though? Science for the forensics, like forensic science. That's the hardest major here. Mhm. Like those be the people that like they be testing the dead body, trying to figure out why it died. Kind of thing. They take mad stuff, biochemistry, physics, all kinds of things. Yeah. Yeah. Sad thing is, y'all make more money than them, but it is what it is. Man. Yeah. Unless you get like a segment on like the Discovery Channel or something, maybe you might make a little extra money. But all right, so let's take a look at this. Right, what's the LCD here? What's the LCD here? 60. I like that. All right. So I got 13 over 15 plus 17 over 20. How do I make a 15 into 60? What is that? Let's go by 4, right? What you do to the bottom? You gotta do to the top. How do I make a 20 into 60? 3, right? What I do to the bottom? I do to the top. I'm not even gonna hold y'all. What's 13 times 4? 52, okay. Plus what's 17 times 3? 51.
Alright, question.
All over 60. Go ahead.
What if we do the LCD like that, right?
Mm-hmm.
But it's then not the lowest one. You simplify it as it wants to come out the same thing.
Yeah. Like if you just did 15 times 20 and called it a day, like yeah, it'll still work. Yeah, but you gotta reduce it at the end. That's the trick. Yeah. So this is like what, 103 over 60? All right, that sounds good. Because I asked them and they told me the LCD was 60. Yeah.
That's what I'm saying,
30 wouldn't work. Yeah. 45 won't work either. But 60 works. Yeah. Yep.
So basically, I don't know, you just gotta multiply.
Yeah. Once I get the same denominator, I'm good to go. Yeah. Even with subtraction, you gotta get the same denominator first before you subtract, right? All right, real quick, let me just give y'all some notes real quick. All right, ooh, hold on, I messed it up, 1 second. If you doing addition or subtraction? Division, oh yeah, so keep change flip and then multiply straight across, and then reduce the answer. Yeah. All right, so so this is how to add or subtract fractions. So step one, do they have a common denominator? If yes, move on to step two. If no, rewrite each fraction with the LCD, find the LCD, change the fraction to an equivalent fraction with the LCD as its denominator, so they have the same denominator, and then add or subtract the fractions, just the numerator, right? And then simplify your final answer if you need to. That's it. So this is how to add or subtract fractions. So I'm about to show y'all all 4 operations for fractions. This is going to be a little table that's going to summarize everything for you. Trying to help y'all out. So here you go. Yeah. So fraction multiplication. If I have a over b times c over d, that's going to be equal to a times c over b times d. Multiply the numerators and multiply the denominators straight across, right? Fraction division. If I have a over b divided by c over d, that's equal to a over b times d over c. So multiply the first fraction by the reciprocal, the second, right? Fraction addition, right? Add the numerators and place the sum over the common denominator. Fraction subtraction, subtract the numerators and place the difference over the common denominator, right? So to multiply or divide fractions in LCD is not needed, right? And to add or subtract fractions in LCD is needed, all right? So I want to make that point clear.
But like the subtraction is the same thing as the additive subtraction.
Exactly. And then say this real quick. When starting an exercise, always identify the operation and then recall the methods needed for that operation, right? That being said, let's mix it up a little bit. So I have 2 questions here. Question A, what is 5x over 6 minus 3 over 10? Question B, what is 5x over 6 times 3 over 10? All right. So let's try this out. I'm gonna check out A real quick. This is 5x over 6 minus 3 over 10. What should I do first? Right. So I have 6 and 10. What's the common denominator there? 60. 60 is good. Give me something better. 30. Now we're talking. Right? So LCD is 30.
You just have to be like 6 times what equals 30.
Exactly. So 6 times what equals 30? 5, right? But what you do to the bottom, you gotta do to the top. 10 times what is 30? 3, right? So multiply this by 3. What you to the bottom? Gotta do to top. So what do I have now? I got 25x minus 3 times 3 is 9, all over 30. That's my final answer, and I'm done.
Because like you got an X, you can't like.
Exactly, can't be combined, so that's it, right? Let's take a look at B though. B is a little bit different. So I got 5x over 6 times 3 over 10. What should I do? Not keep change flip, that's for division. What should I do? Multiply straight across, right? So 5x times 3, what's that? 15x over 6 times 10, what's that? 60. Now, this could be reduced a little bit, right? By 5, okay, so 5 goes into 15x how many times? 3x, and then 5 goes into 60 how many times? 12. So I have what? 3x over 12. I could do better than that though, right? Okay. 1/4, right? So 3 goes into 3x x times. 3 goes into 12 4 times. So final answer, x over 4. That's it. Questions on this? It's just combining all like everything together. All right, so basically look at when you get a question, right? Look at the middle thing. Like, what are they asking you to do? Multiply, add, subtract, divide, whatever, right? And then apply the appropriate rule to it. That's it. Here, you guys try. Oh, if you guys want to work together on y'all homework too, please go ahead, exchange numbers and all that. I can do y'all thing, No, I'm saying if you guys want to work together, like, to do y'all homework, like, as a group. Also in tutoring, they do group tutoring as well. So if you guys want to go as a group together, y'all are welcome to do that. So like 2, 3, y'all wanna sit down with one tutor, doing the same homework. That's cool too.
Hey, I got a question.
Uh-huh.
When we trying to do the LCD,
Mhm.
why we just don't time them together?
You can. That's
Alright,
legal.
You want to talk about this one?
Yeah.
Alright.
You could find a common denominator by just multiplying them together and then just simplifying at the end. That's fine. Yeah,
Because 9 times 4,
Yeah.
blah, 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 4 times 5 equals.
exactly. Mhm. But like I said, I'm cool. All I want y'all to do is get 100. How y'all get your 100? Like that's up to y'all. Go ahead.
Yeah, like.
Say it again. Oh, they're on web work. Yeah. Did you see the announcements on Brightspace? Got you. What I really recommend, there's a app. They have it in both the Play Store and the App Store. It's called Brightspace Pulse, right? I highly recommend you guys download that. It'll work for all your classes. Anytime there's an update to the class or something, it'll send you a message immediately on your phone, like something just updated in your class. But I always do like announcements after. Go ahead. Brightspace Pulse, like Pulse. It's orange and it looks like a, like, you know, like when the heart monitor with the pulse, it looks something like that with like the wave and stuff. That wave happens to be a sine, cosine. Y'all get into that later. What you guys think about this room? It's doable. Oh, yeah. All right. It's my first time in this room. So. When I was here, I took like the easy physics, like physics 12. So this is for like the advanced physics people. You know?
After this one, right? I'm lost.
So now this is for A, right? Yeah. So this is a subtraction problem. So we got to get the same denominator and then do the subtraction. This one, that's a multiplication problem. So you just go straight across.
All right, thank you.
All right, let's take a look. For this first question, I have 3a over 4 minus 8 over 9. All right. So this is a subtraction problem. So in order for me to subtract, I have to have the same denominator, common denominator. So what's my LCD over here? 36, very good. So this is gonna be 3a over 4 minus 8 over 9. How do I change the 4 into the 36? Times 9, right? What I do to the bottom, I gotta do to the top. How do I change a 9 to 36? So that's 4, right? What I do to the bottom, I do to the top. And after that, just do the math on it, right? 9 times 3, what's that? 27a. Minus 8 times 4, what's that? 32. All over, what's this? 36? And that's your final answer. That's all you got to do.
You don't reduce 32 to 36?
Nah. We don't reduce that. I mean, hold up.
Good though.
Is there a common number that goes into 27 and 32?
I'm talking about 32 and 36.
Nah, it has to be individual. Like it'd have to be like a common factor for both to reduce down.
27 and 32.
Right, right. Let's look at B. I have 3A over 4 times 8 over 9. What do I do here?
You change the flip.
No, it's division.
Oh, no, I'm sorry.
Multiply straight across, right? So when you multiply straight across, what do we get? 27, is it? 24. 24A over 36. But I could reduce this a little bit, right? 2 over 3, right? So this becomes 2A over 3. And then that will be my final answer. Questions? What?
I got 36. Like
36? 9 times
like
4.
the bottom part, if you just start off with like those two fractions, I got 36.
So it's the 4 times 9 is 36. Yeah. And then the 3 times 8 is a 24A. And that's it. Yeah. Simple, simple. Do we need to see another one or we feel good on this? We good? No one of them? All right. It'll be like that sometimes. All right, try that out. You know?
This for the same one. It says that it was another building. Says here,
It's here.
that's no, because of the top one is over here and it says Norfolk for the second one.
It's really weird. Nah, that should be here. Hold on. Let me check something. Nope, it's here. The whole thing.
Okay.
Yeah, it's like 5. Yeah,
Alright.
yeah. However, like, on Thursday though, we online. On Thursday, we online. That's the only thing. Yeah, yeah. They're in the announcements. Like the announcements that I leave on Brightspace. Yeah. All right, let's take a look. So I got 4K over 5 minus 1 over 6. What am I gonna do there? Very good. And what is it? 30, right? So what do I have to multiply the 5 by to get 30? 6, right? But what I do to the bottom? So, right? What do I have to multiply the 6 by to get 30? 5, right? What I do to the bottom? I do to the top, right? Multiply this out, what's that? So this is 12, 24K minus 5 over 30, and then that's it. Questions on that, or we good? Like 30? 5 times 6.
Just times the bottom is by each other.
Yeah.
It's times it by each other.
Yeah.
And if anything was too high, you do.
It'll always work. Yeah. All right, B's a little bit tougher though. Right? So I got 4K. Yep, that's it. Yeah. So 4K over 5 times 1 over 6. I want to multiply these, so what do I do? Straight across, right? So 4K times 1 is what? 4K over 5 times 6 is what? 30, right? But I can reduce this a little bit, right? All right, good. So 2 goes into 4K 2K times, and 2 goes into 30 15 times. So final answer, 2K over 15. And that's it. We good? All right, awesome. Let's jump to our next topic. This one's even easier than the, oh my gosh, it's so simple. The next one is so simple. So what we gonna be doing, right? We want to evaluate variable expressions with fractions, right? So we have evaluated expressions before, but now we can evaluate expressions with fractions. Remember, to evaluate an expression, we substitute the value of the variable into the expression, and then we simplify. So let me show you what we're talking about. I think we did this last week too, right? It's math simple. Say I got 2x squared y when x is equal to 1 over 4 and y is equal to negative 2 over 3. Simple, right? So everywhere I have a variable, I'm going to write a parentheses, just like that. Now x is 1 over 4, so I'm going to write 1 over 4. Y is negative 2 over 3, so I'm going to write negative 2 over 3. That's it. Just do the math on that, right? Real nice and simple. You already know 2 is going to become what? 2 over 1. And 1 over 4 becomes what? 1 over 16. Now we're talking, right? Because remember, the 2 is going to apply to the numerator and denominator individually, right? And then, yeah, so 1 over 4 squared becomes like 1 squared over 4 squared. All right, and then 1 times 1, 1, 4 times 4, 16. Yeah, that's what that means. I'm gonna just put a little thing over here just so we know that's not part of the question. And then I have the negative 2 over 3 still here, all right? Now nothing's changed. Even though I'm multiplying 3 fractions, how do I multiply fractions? What do I do? Straight across, right? So 2 times 1 is 2. 2 times negative 2, negative 4, right? On the bottom, 1 times 16 is 16. 16 times 3 is what? 48, all right?
Wait, you go back up.
Okay. What's up? Up here, oh, I got you. Now, I can reduce this a little bit, right? This negative 4 over 48. Hold on 1 second. Pen not right? We could reduce that to over 24. like that. I could reduce that again though, right? Right, so -1/12. And then that's my final answer. Right? Not so bad, right? So long story short, you take what the variable is, you plug it in, do math on it, get the answer, that's it. Alright? Alright. You're welcome. Let me let y'all try one. I mean, yeah, there's people that did that. Ooh. Try that out. You good? All right, let's give this a try. So I got 3ab², right? So everywhere I have a variable, I'm gonna write a parentheses. And then I'm just gonna write down the value of the variable where it belongs, right? So this is -2/3, and this is -1/2. Let's convert these into fractions. So we know that the 3 is gonna become what? 3/1. Exactly, 3/1 times, we still got the -2/3. And then -1/2, what's that gonna become? Huh? 1/4, excellent. All right? And then after that, just keep it simple, just multiply straight across, right? So 3 times -2, what's that? -6, and -6 times 1 is -6. And then over 12, good. I could reduce this a little bit, right? So, well, -1/2, right? Boom. And then that's it. Yeah. You know how you got it? Because you're smart. Y'all doing great. That's what that is. You know? Y'all want to see another one? The three. Oh, because it's a whole number integer. So remember, integers can be written as the number divided by one. So I'm doing that so that I can recognize how to do the multiplication straight across, you know? Yeah. Yeah, yeah, there's nothing there. Because the last one was squared, right? So this is actually, this one right here is like -1/2 squared, which becomes what? -1 squared over 2 squared. So that's the one positive 1/4. That's where that comes from. Let me give you guys another one real quick. All right, try that out real quick. For real? Dang. When I was in high school, I had math every single year. My partner got you. Nah, I wish he was here back in the day, man. Like, because CUNY, they used to have remedial classes, so they never used to expect that you know anything. They just built you up. Now they just throw you into this class and it's like, yo, sink or swim, you know?
Like, they said my math school, I was boring. They said my math, I passed math over there. They said it wasn't good. So now, pass it.
Hey, no. You probably went to Morrisville back when they had the remedials. Cause I think they got rid of them too.
I was there before COVID.
Yeah.
Right before I stopped.
Yeah.
COVID hit, and I was like,
Yo, COVID hit and you ain't come here?
COVID hit, I went to Florida. Then I just moved back out.
Yo, when I tell you that Peoples was running through your program over here,
I know.
like running through,
But
like,
look, teacher, yeah, failed me because, so I'm going there every Monday and Wednesday.
yeah.
The class is on Fridays too, but you never tell me. So he failed me off for the shit. It's all pissed off.
Sorry about that, man.
But I was like,
Yeah, man. All right, let's give it a try. So I got 4c cubed times d, right? So what am I gonna do? Everywhere I have a variable, I'm gonna write a parentheses, cubed. And then I just wanna write in the values of those parentheses, right? So this is gonna be a -1/2. And this is gonna be a -4/3. And then now let's write them as fractions, right? What does a 4 become? Exactly, 4/1, put that in parentheses. What about this -1/2? What does that become? -1/8, very good. And then just write down the -4/3. After that, just multiply straight across. 4 times -1 is -4. -4 times -4 is, right? Very good. That's 16. Now 1 times 8, we know is 8, and 8 times 3 is 24. And I can reduce this a little bit, right? By 2, right? So this would become,
We saying it ends at 2.
what ends at 2/3?
I said 4-2.
Okay. Let's see, if we reduce this by 4, this would be 4, hold on. This thing is frozen, 4/6, all right, then reduce that by 2. I give you 2/3, yep. Not bad. Questions on this? Oh. All right, well, can I borrow a piece of paper from somebody, please? Some blank piece of paper. Wanna use that for attendance, so just sign it and y'all free to go. Mhm. Yes, appreciate it.
You get back for it,
Right? I'm just gonna write this down. Oh, just sign it and y'all free to go. If you guys wanna stick around for a little bit, do y'all homework together, go ahead, be my guest. Freshman, yeah. It's good. The homework is on WebWork, right? But you could get the link off of Brightspace. Okay? Yeah, you're welcome, yeah.
The second class, I just remember where it says my phone.
Yeah, no, there's no second class, that's it.
Alright.
Yeah, you're just here, yeah. Can I take this down? It's okay?
Yo.
Go ahead. Got you, so negative. One second. Sorry about that. So the -1/2, right? That's cubed, right? This is gonna become -1, you too, -1 to the 3rd. You too, man. Over 2 to the 3rd. So the -1 to the 3rd, right? That's like -1 times -1 positive 1 times -1. This is gonna become -1 over 2 to the 3rd is 2 times 2 times 2, so 2 times 2, 4, 4 times 2, 8. That's how that became like that.
Okay, nice to meet you.
Nice to meet you
It's
too,
your
yes.
today.
Yes,
I'll see you on
please.
Thursday.
Yes, no, I got you.
Yeah.
Yeah.
Like I said, I missed that first homework, so like, I'm done on it.
No, just do it.
Just do it?
Yeah, it's online on WebWork. Yeah, yeah. It's the same link, login, yeah. All the homework's just gonna be uploaded there, so just keep logging in and just knocking it out.
Cause the days when we had class online, I was here trying to figure out what the hell I.
How to do it, I got you.
They gave me in there.
Yeah. So go to WebWork, right? Yeah, there's a link on Brightspace for it. Just click there and then just log in. The login is your first name and then your last name together is one word. No space. WebWork, yeah. No space, no dot, anything like that. Now I could take this down. Is this okay? One second. Hold on. I'm Chris Lee.